You probably know why you want to build a certificate authority. We will not discuss that. Today, we will see how to build an automated certificate authority or CA in our Devlab. We will first automate creating a root certificate and an intermediate certificate. We will also automate getting a signed certificate for a host. Then we will apply it on a complex situation, which is operating our Devlab's Proxmox virtual environment host, the PVE, with a certificate signed by our CA. A traditional certificate authority consists of three parts: a cryptographic engine, some signing certificates, and an agent that people install on their hosts to manage certificate renewal and billing. The standard cryptographic engine nowadays is OpenSSL, which can be used to create certificates. We can create as many certificates as we want with OpenSSL. However, to build a certificate authority, we need to establish a chain of trust, which means signing some certificates using other certificates. We will see how to do that today. A traditional certificate authority has a root certificate and a collection of intermediate certificates signed by the root certificate. The root certificate signs only intermediate certificates, and intermediate certificates sign other certificates that can be used in different tasks on different hosts. Like, for example, to encrypt traffic, to sign documents, but not to sign other certificates, because that is the job of a certificate authority. When we need a certificate for a special purpose, we sign it with the appropriate intermediate certificate for that purpose. We will use our Ansible controller to eliminate the need for a certificate agent, something like certbot, for example. The tools we will build today will be flexible and will work well in an agentless mode. To keep our code simple, we will create only one intermediate certificate. Let's start. This playbook will build a new LXC container that is designed for hosting our CA. This will be our CA host. The first play in this playbook looks familiar, with a small change to what we used to do before. Before, I used to pass recreate on the command line. Now, to avoid mistakes, I'm putting recreate inside the playbook with false, so that we don't delete our certificate authority by mistake. Now I will change it to true for testing, but then after testing it, I will change it to false. And I will let it run while we are exploring the CA role. This is a new role that we created only for the CA. First, I want to set up some directories because I will need them to store files. These are file names that I will store on these directories. We start by upgrading our packages. Although this is a Debian host and I can use the Debian base role, I don't want to use that on this host because I want to maintain as much security as needed as possible for this. So I don't want a dev user. I don't want to use this host for any development, anything other than signing certificates. So now we finished and we have a new host. Then we upgrade the packages on the host and we install the required dependencies, which are in this case the Python 3 cryptography module. We need directories to store our certificates, so I will create two directories, one for the root directory and one for the intermediate directory. Then we start by creating the root private key, which is required for the certificate, and we give it a passphrase that we get from our vault. So our vault template was updated to include two passphrases, one for the root private key and for the intermediate private key. Back here, so we create a private key. By theory, this private key should remain on the host and never be transmitted by electronic means, should not be transmitted on any network. So to save this private key, we need to save it on a USB drive, or like in a way that does not include transmitting it over a network. We create a certificate signing request for using our private key, and we tell the certificate that this is a certificate for a certificate authority. We self-sign our certificate using our private key. So this will be a self-signed certificate. The root certificate is self-signed, and this will be the root of our chain of trust. We are using here the community.crypto collection and the models in this collection. Links to the documentation of these models will be in the article. The article link will be in the description. Notice here that we use BIBE, the certificate. We generate the certificate with BIBE, which means I want to store this certificate in the memory because I want to copy it to the base Debian and the base Fedora that we created in the previous 2 episodes. Every time I run these roles, I deploy the new certificate that I just created, the new root certificate that I just created. So now this role will update our code base. This will generate commits. Now we can create the intermediate certificate, and here also we create it with password protection, and we use the file names that we specified earlier. We create a signing request. Also, this signing request will be for a CA. It's identical to the signing request that we created for the root certificate, but with the exception that we sign this intermediate certificate with our root certificate, with the private key of the root certificate. So we use the signing method, the signing certificate in community.crypto, and we pass our own CA, and we pass the information for our own CA. This certificate will be valid for more than 2 years, which is enough for a root, for an intermediate certificate, and those should be renewed from time to time. The root certificate is not time bound. So now this is the role that will create our certificate authority, that will configure our certificate authority on the host that we run the playbook against. We have some defaults here. We are not passing any arguments. I put everything in default. So the folder name will be Devlab, and I'm using here, and this will be the name of the certificate authority. Let's look at our host. I am here on my development machine that is connected to the Devlab, and I see host 110, which is the Devlab CA was created. If I go inside, I see that I have two new directories, root and intermediate, under etc/devlab_ca. I go to root and I check my files. I see that I have a new root certificate. So let's cat that root certificate. .pem. .pem is the certificate. .key is the key, and .csr is the certificate signing request. So this is our certificate. It is in a format we call PEM. This is data encoded in base 64 with this introduction and end. It starts with MIIFH, and if I look at my code here, if I look at the base Fedora task, sorry, I want to look at the certificate, and I see MIIFH, and the close is FUKD. The end is FUKD, and this is the start. So apparently we have the same certificate, and I can check also that I have it in base Fedora as well. So yes, this looks the same certificate. So now we have our root certificate and our intermediate certificate. We are ready to sign certificates for other people. The first certificate we will sign is for our PVE, and to do that we want to create a new role for signing certificates. The new role, I'm calling it SSL underscore server because I have a new role later for X509's client certificate when we want to do two-way SSL or TLS. In this role, first we start by creating a directory for the certificates. Then we create a new private key for this host, the host that we are operating on. But this private key does not have a password because some servers do not support a key with a password. They need the key to be without a password. We create a certificate signing request also on the host that we are operating on. Then we sign the certificate. Notice that the signing happens on the certificate authority host, not on the host that we generated the private key on. So what we are doing is we are creating the private key on the host. It remains on the host, never leaves the host. What we move to the certificate authority host is the signing request. So we have the signing request here. We pass it to the signing X509 certificate pipe, and we use pipe here because we want to keep it in memory as we have seen before. The certificate is now signed. Some servers will take this base certificate that we generated here as is. Some servers require this certificate with the intermediate certificate. Some servers require this certificate with the intermediate certificate and the root certificate as well. So to prepare to send all these to the host that requested this certificate, we load them in memory. This model here, the slurp model, will load a file. As you have seen, it gets a file and it loads it and it encodes it in base 64. So when we output it, we need to decode the base 64 data. So we load the intermediate certificate and the root certificate, save the signed certificate on the host. We save the intermediate certificate, which is the signing certificate. Now we used it to sign, so it's our CA certificate for this certificate, and we save the root certificate as well on the host. Then we save the signing chain. So we save the signed certificate plus the signing certificate. We save the signed certificate plus the signing certificate plus the root certificate in the same file. Also in the same directory. This one we call it underscore chain, and this one we call it underscore full. Then we generate the bkcs12 file .p12, which is used for some servers and sometimes used on Windows. Sometimes, like I think Jellyfin on Linux uses this format, if I remember correctly. I'm not sure. So now we have the role. We have generated the certificate. As you see, generating a certificate is not a complex thing. You generate a private key, a signing request, then you sign with your own certificate. There is some considerations for security, and Ansible helps us a lot with that and simplifies the process a lot and allows us to hop between hosts from this host to this host. We do 3 operations on this host and we copy data in memory and we use it in the other host. So like Ansible is fantastic for this type of host hopping. Now we need to test this role, and to test it, if you remember, we still did not create a playbook for the maintenance of our PVE. If you look at our repository, there is no PVE role here. So we created the Devlab PVE playbook, sorry, not role, playbook. So we create the Devlab PVE playbook. In this playbook, we run this role, the SSL server role, with options that I will show you with the variables. And then we upgrade all the packages, and we need to do a hack here because this the Ansible built-in copy model did not work on this directory in Proxmox. There must be some configuration, some issue that I did not understand, and there is a forum post on this on how to solve it. My solution is to use the system CP model and to bypass Ansible copying via Python. So we copy these two files to specific places in the BVE, because the BVE like requires that the new certificate should be put in this file, and the private key should be put in this file. So, and also the BVE requires the chain certificate, not the single certificate. You need to supply the chain. Then we restart BVE proxy, so we restart the BVE interface. Let's run this role and see what we get. So we copied the certificate, we are restarting the host, and now we are done. So if we look here, it was restarting. I think it restarted now. Show me the console again. You see, we had like an exception for the trust here, and let's restart it again. So we need to add a new exception now because the certificate was changed, and the error here, unknown issuer. So if I trust it, like the certificate works, and if I check the certificate here, connection is not secure. More information, view certificate. I see a certificate signed by the Devlab Intermediate Certificate Authority, and this is the Intermediate Certificate Authority signed by the Devlab Certificate Authority, and there is no information on this. Is LibreWolf. It does not know who is this certificate authority, so that's why it said unknown issuer. By now we have solved the server problem, but we have not solved the client problem. In the next episode, we will solve the client problem, and we will install our certificates on our clients, and we will see how we can use them in the previously created roles. Building our own certificate authority is not a complex task, although it involves encryption and some of the scary terms in computing. It is easy when we do it with automation and with Ansible, and Ansible allows us to make it repeatable and to streamline the creation and renewal process very easily. The challenge with building a certificate authority is to establish the chain of trust. The chain of trust across multiple parties is a complex task, and for that you might need an agent, the way that people like Let's Encrypt have solved the establishing the chain of trust problem. We did not need an agent in our system because we are trusting our own authority, and there are no third parties, not even second parties. There is also only one party that is trusting their own certificate. If you need to establish trust across multiple parties, maybe the only solution would be an agent, something like Certbot or what Let's Encrypt is building. And the choice is yours. If you can have your own certificate authority with Certbot using open source solutions like StepCA, for example. In the next episode, we will be trusting our authority on many of our devices. In the Devlab, for example, we will trust our certificate authority. We will solve some of the problems using Ansible, but we will not be able to solve all the problems. I'm still working on the Docker and Swarm GitLab Runner episode. I hope it will be ready next week. And then we will go back to the Linux router and build our fully functional Linux router with Ansible. And then we will go back to other development projects that we will use build in our Devlab. I would like to thank all the people who have supported me, all the people who have signed up for my channel, and all the people who liked my videos and commented on them. I hope you will be following me after this episode, and I hope to see you in the next episode.